Okay, hello. I'm going to do a few things, an example here that I think might be useful for your assignment and that I think were left out of the intro to Sage that we did in the computer lab. So first, in every worksheet, I'm going to start with typeset output because I like to see the math nicely. So I'm going to evaluate that cell. So Shift Enter, remember? Okay, and now everything I type would be outputted like a nice math. So I'm going to talk about vectors. So first of all, if you do this, you might, I think students do this, I don't know if on purpose or on accident. If you call it V and you do 1, 2, 1, comma, 2, comma, 3, so I put a parentheses and inside a bracket. That's how you do a vector almost. So I put parentheses in bracket and put a 4, 5, 6. I'm going to make them display these, so I do V. When I'm pressing enter here without shift, I get to a new line, and until I press shift enter, I evaluate the cell. So right now there's no output because I didn't tell, I'm just telling Sage that these are my objects V and W. But now I'm going to tell him to display my V and W, so press enter, and I can do like V, then colon and W, and then do shift enter, and now those two objects get displayed. So these look like vectors, but they are really not because, for instance, if you add them, I get something strange that is not a vector. So, I mean, it's a 6 long instead of 3. So what this addition is doing is putting one vector or one array, these are really lists after the other, making a longer list. Yeah, I think the term is concatenating the list. So this addition is not what we want. If you type the word vector in front of these, then you are saying these objects are not just lists, but they are vectors. And now they are in parentheses. And if you add them now, it adds them like I think it should. So just be careful with that. To define a vector, you need to write the word vector here. Something also that we didn't talk about is that I might, for example, if I might, I would make this vector called U equals the sum of V and W, and now, so nothing happened. It just knows that U is the sum of V and W. If I type here U, then U is the 5, 7, 9. For some instances, you might want to read the entry of a vector. So for example, say I want to read that 7. So that 7 is the second entry of the vector. So in Sage, or I think this is Python, I'm writing U, and you put in between brackets the index of the place you want to read. Now in any computer language, it starts from 0. So the 5 would be U0. If I put 0, it's going to read the 5. If I type U1, it reads the 7. And of course, if I type the 2, it reads the 9. If I type U3, it's going to spit an error because there's nothing. Yeah, it would be a first term. Remember, it starts from 0. So U0 would be the 5, U1 would be the 7, and U2 would be the 9. But now I can just add these. I can do stuff like U2 plus 3 times U1. And it's a 30 because I did U2, which is a 7, 3 U1s, sorry, U2, which is a 9, and 3 U1s, which is 21. So 21 plus 9 is 30. Okay, so this is going to be useful. You see, maybe you don't see exactly why yet, but in a minute you'll see. I hope you make the connection with the problem from the worksheet. So the other thing I want to tell you is that you can also create a, I'm going to erase this. You can also create a vector that is a function. So I'm going to erase this. I'm going to write f equals vector, parentheses, bracket, and I'm going to type x. I'm going to write x plus 1, and I'm going to type something like, how would I write x plus 2 squared over x squared plus 1. So if I tell you what f is a vector that looks like that. So I can evaluate f at points. It gives me a warning because I think when you type a function, it doesn't like it at first, but it will do it. So just do it again, and it will not give you the warning anymore, I believe. Okay, so it's a 16, then it's a 5, and if I write 4 plus 2 is 36. When you square it, and the bottom would be 16 plus 1, 17, right? So that's this. Of course, you can make it as long as you want. I just stop there, but you can do. So now you have an idea why this might be useful when you're dealing with these polynomials. Oh, I didn't evaluate this one. Right? F of 2, for example. This might be important. F of 1 is that important. So you might want to use this to organize your coefficients of your polynomials on point number 1. Now you don't have to. I'm saying that this might be useful. And then if you want to read, for instance, who is the F when you evaluate 5, entry number 2, so it's going to spit out the 49 over 26, right? Because this is the entry 0, 1, and 2. So if I do F5, let me evaluate a different point. If I do F evaluate at 2 in the last entry, which would be 0, 1, 2, 3, 4, it should spit out 2 to the 5. And 2 to the 5 is 32. Okay, so this might be useful when you do when you evaluate those things. Now, why is that useful? Well, something that I think I said is that you can write a matrix, and maybe now you're getting the idea of where I'm going with this. And you can write here, I'm going to put, how about I do the vector, for example, I can just do the vector, I tell them what size, so it's going to be, I'm going to do 3 by, these are size 1, 2, 3, 4, 5, so 3 by 5, and I'm going to put, how about if I just do f of 0, comma, f of 1, oh sorry, f of 1, f of 2, f of 3, and f of 4. If I do this correctly, I think it's going to display a matrix of just 3 by 5. So I'm doing this wrong. I only want, sorry, I'm doing this wrong. I only want 3 of these vectors if I do that. Right, so the 3 goes down, so each one of these entries would be a row, and each output would be a column. Sorry. It should be doing that. Oh, sorry. Then tell it to display this. Yeah, so what it's doing is it's evaluating f of 0. This has length 5, right? That's my first row. So my function is up here, right? When you evaluate 0, you get 0, you get a 1. Here you get a 4, here you get a 0 and a 0. Then you evaluate f of 1, and it's reading that and putting it in the second row, and it's evaluating f of 2 and putting it on the third row. Okay, so I think this might be helpful for what you are going to do on problem number 1. Again, you don't have to use this if you don't see the connection, but for most of you, for a few of you that are have done a little bit of computer usage in other classes, this might make a lot of sense. And if you haven't, well, try to think how you would use this on problem number 1, and it will probably help you to keep things organized. Okay, so yeah, I hope you find this useful.